Hello friends, welcome to the video on Introduction and Applications of Laplace Transforms. I am Dr. Naveen Joshi, Associate Professor, Humanities and Sciences Department, Srinivasa Ramanujan Institute of Technology, Anantapura. Introduction and Engineering Applications. Laplace transform in mathematics, a particular integral transform invented by the French mathematician Pierre-Simon Laplace and systematically developed by the British physicist Oliver Heaviside to simplify the solution of many differential equations that describe physical processes. Laplace transform has important applications in mathematics, physics, engineering, and probability theory. Laplace transform makes it easier to solve increasing complexity of engineering problems. The concept of Laplace transform play a vital role in diverse areas of science and technology such as electric analysis, communication engineering, control engineering, linear system analysis, statistics, optics, quantum physics, solution of partial differential operation, etc. In solving problems related to these fields, one usually encounters problems on time invariants, differential equations, time and frequency domains for non-periodic wave forms. Laplace transform is used for analysis of linear time invariant systems such as electrical circuits, harmonic oscillators, optical devices, and mechanical systems. In this analysis, the Laplace transform is often interpreted as a transformation from the time domain in which inputs and outputs are functions of time to the frequency domain, where the same inputs and outputs are functions of complex angular frequency in radians per unit time. The Laplace transform has useful property that many relationships and operations over the originals correspond to similar relationship and operations over the images. Now let's see the definition of Laplace transform. So the Laplace transform definition, L of f of t L of f of t is equals to capital F of s. Here L represents Laplace transform operator. F of t means clearly the function of t. Okay, so f of t is a function of t. It represents the time domain. So your LHS part representing the time domain. So after applying Laplace transform, so whatever the things we are getting on RHS, so it is in frequency domain. The transformation from time domain to frequency domain takes place by the operator Laplace. Okay, so Laplace operator L we are using. So L is the Laplace transform. Okay, so Laplace transform of the given function gives the function in terms of frequency. Okay, so here the main mathematical representation of Laplace transform, mathematical definition is capital F of s is equals to integral 0 to infinity f of t into e power minus st dt. So LHS side we are having L of f of t. So here we know that capital F of s is nothing but L of small f of t. So L of f of t is equals to integral 0 to infinity f of t e power minus st into dt. This is the mathematical notation or the definition of Laplace transform. Here L we are saying that L is the Laplace transform operator. Similarly, L inverse represents inverse Laplace transform operator. Means L is we are using Laplace transform operator L we are using to convert time domain to frequency domain S. So for that we are using the Laplace transform technique, and to convert again from frequency domain to time domain, we are using inverse Laplace operator. Okay, so this is the major definition. So in several concepts, we are going to use the definition of Laplace transform. Usually we are going to choose one real life problem. So always the real life problems are existed in time domain. So what are the problems we are facing? So we are facing some of the difficulty while solving the problems in time domain. Therefore, we are going to convert the particular problem by applying Laplace transform. We are getting the solution in terms of frequency domain. Again, to come back to the time domain, we are going to apply inverse Laplace transform operator. Then we are getting the solution in terms of t, that is time domain. So there are several lot of applications. Also, we can solve many differential equations which are arising in engineering and technology. Okay. So with this, thank you for watching the video.